Impact of a stellar intruder on our solar system. This is on phys.org by the Max Planck Institute. And we many a time hear, for example, those who are studying and analyzing the quakes and the geologic activity on Earth, planet alignments, and the black star, brown dwarf star, the intruder in our solar system, calling it the stellar intruder. And obviously it's because they've studied what Max Planck has analyzed, and they use the same term. This was last year's article, but I never read it. I had just picked it up today. I think it's very interesting because of the fact that this would be going on. It talks about what would be going on in the case we do have a foreign body, another planet, another substantially sized object nearing Earth. Now, the solar system was formed from a protoplanetary disk consisting of gas and dust. Since the cumulative mass of all objects beyond Neptune is much smaller than expected, and the bodies there mostly have inclined, eccentric orbits, it's likely that some process restructured the outer solar system after its formation. Susan Fasner of the Max Planck Institute for Radio Astronomy in Bonn, Germany, and her colleagues present a study showing that a close flyby of a neighboring star can simultaneously lead to the observed lower mass density in the outer part of the solar system and excite the bodies there onto eccentric inclined orbits. And we know that NASA and other astronomical bodies, agencies have told us that the planets of our solar system, the ones at the edge of our solar system, have tilted and their orbits have shifted, and that something must be out there changing the orbits and the tilts of these planets. Their numerical simulations show that many additional bodies at high inclination still await discovery, perhaps including the sometimes postulated Planet X. Now, after this, I want to concentrate on some materials concerning people that have images and videos of some foreign object very close to our sun, some anomalies in the sky. Well, let's just call them anomalies for the sake of being conservative. But they look like they're other bodies. And you can see them with the naked eye. So I think it's important for us to know what's out there. Many of us don't have the time to look at the sky and sit there and examine for hours what we see. I guess if we do have the time, a couple of days during the week to do that, we will definitely see things that we didn't know were there. But let's go back to this now. The findings are published in the Astrophysical Journal. A near catastrophe billions of years ago might have shaped the outer planets of the solar system, while leaving the inner regions basically untouched. Researchers from the Max Planck Institute of Radio Astronomy in Bonn and their colleagues, the collaborators, found that a close flyby of another star can explain many of the features observed in the outer solar system. Quote, "Our group has been looking for years at what flybys can do to other planetary systems, never considering that we actually might live right in such a system," end quote, says Susan Fasler, the lead author of the project. She says the beauty of this model lies in its simplicity, end quote. The basic scenario of the formation of the solar system has long been known. The sun was born from a collapsing cloud of gas and dust. In the process, a flat disk was formed in which large planets grew, along with smaller objects like the asteroids, dwarf planets, etc. And due to the flatness of the disk, the planets would be expected to orbit in a single plane unless something dramatic happened. looking at the solar system right to the orbit of Neptune, everything seems fine. Most planets move on a fairly circular orbits, and their orbital inclinations vary only slightly. But beyond Neptune, things become very messy. The biggest puzzle is the dwarf planet Sedna, S-E-D-N-A, Sedna, which moves on an inclined, highly eccentric orbit and is so far outside that it could not have been scattered by the planets there. Just outside Neptune's orbit, another strange thing happens. The cumulative mass of all the objects dramatically drops by almost 3 orders of magnitude. This happens at approximately the same distance where everything becomes messy. It might be coincidental, but such coincidences are rare in nature. Susan Fassner and her co-workers suggest that a star approaching the Sun at an early stage, stealing most of the outer material from the Sun's protoplanetary disk and throwing what was left into inclined and eccentric orbits. Performing thousands of computer simulations, they checked what would happen when a star passes very closely and perturbs the once larger disk. It turned out that the best fit for today's outer solar systems comes from a perturbing star with the same mass as our Sun, or with something lighter, like 0.5 to 1 solar masses, which flew past at approximately 3 times the distance of Neptune. However, the most surprising finding was that a flyby does not only explain the strange orbits of the objects of the outer solar system, but also gives a natural explanation for several other unexplained features of our solar system, including the mass ratio between Neptune and Uranus, and the existence of 2 distinct populations of Kuiper Belt objects. Quote, "It's important to keep exploring all the possible avenues for explaining the structure of the outer solar system. The data are increasing, but still too sparse, so theories have a lot of wiggle room to develop," end quote, says Pedro Lacerda of the Queen's University Belfast, a co-author of the paper. Quote, "There is a certain danger that one theory crystallizes as truth not because it perhaps explains the data better, but because of other pressures. Our paper shows that a lot of what we currently know can be explained by something as simple as a stellar flyby. The big question is the likelihood of such an event. Today, flybys, even hundreds of times more distant, are fortunately rare. However, stars like our Sun are typically born in large groups of stars that are much more densely packed. Therefore, close flybys were significantly more common in the distant past. Forming another type of simulation, the team found that there was a 20 to 30% chance of experiencing a flyby over the first billion years of the Sun's life. This is no final proof that a stellar flyby caused the messy features of the outer solar system, but it can be reproduced many observations and seems relatively realistic. So far, it's the simplest explanation. And if simplicity is a marker of validity, this model is the best candidate so far. Quote, "In summary, our close flyby scenario offers a realistic alternative to present models suggesting to explain the unexpected feature of the outer solar system," concludes Susan Fassner. And she said it should be considered as an option for shaping the outer solar system. The strength of a flyby hypothesis lies in the explanation of several outer solar system features by one single mechanism, end quote. This is by Max Planck Society on phys.org. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.